Well, I'm talking about love of Jesus Christ. And I'm talking about peace that Jesus gave. Listen, because He laid on His life and He took it again, and He gave us a victory. Well, I'm talking about peace. He gave us peace and love. Well, I'm talking about joy.
Yes, students. Welcome to our today's lesson with your favorite teacher, Sergio. Today, we are going to look at trigonometry. And then we'll be looking at trigonometry and its practical applications. First of all, when we say trigonometry, what does it really mean? Trigonometry is just how we can find angles when we are given specific planes. Okay, so in a two-dimensional plane of figures, how do we determine the angle? Okay, now we have certain identities, we call them trig identities, which we may look at in this particular lesson, and then we have ones that we shall consider at the early stages. Now we have properties like cos, we have tan, we have sine, and the rest. Okay, so that is what we are going to be looking at generally. So imagine I've given you two plane figures, okay, two plane figures, and then I told you this one is inclined at this angle, the other figure is also inclined at a different angle. Now find the height of inclination, the spaces between the base from where you are looking at, and all that. So we shall be treating that in this particular lesson. Okay. So now let's take and look at certain trig identities we have. For instance, you might have heard of cosine. Okay, cosine, and then we have sine, and then we have tangent. So we have cosine, sine, and then tangent. These are the three basic ones, okay, that in this scope of lesson we shall be looking at. These are the three basic ones. Now the cosine, normally it is denoted as cos, and then the sine is denoted as what? Sine, and then the tangent is denoted as what? Tan. Okay, so these are the three basic ones. But there are more. There are the opposite of this one is called the cotangent. Okay, the cotangent, that is the inverse of the tan, is the cotangent. And then, let me continue. Cotangent, and then the inverse of the sine is called cosecant, and then the inverse of the cos is called secant. Okay, secant. There are more. Okay, there are more as to this effect. But then we will be focusing more on these three. Right. Now, these trig identities we have here, these trig operators, right? Let's say they are called operators. So let's say these trig operators we have here always perform a certain task to give us a value when you are given an angle. So for instance, you always see a cosine with an angle. So you see cos, maybe the angle is called theta, and then you see sine with its corresponding angle, maybe the angle is called theta, and then tan too with its corresponding angle, say theta. So that is how you will be seeing it: cos, sine, tan, and the rest. So you'll be looking at this. Okay. Now let's establish a relationship between these three. Let's establish a relationship between these three quantities we have here. Now cosine and then sine, they are just 90 degrees out of phase with each other. What I mean by 90 degrees is that the sine of say an angle 0, the sine of say an angle 0 is equal to the cos of an angle 90 degrees. Okay, so meaning that as this is increasing, This is also what? Reducing. So let's say this goes to 1, this will go to 89, and it goes like that. So always the angle difference between the two is 90 degrees. So if you plot them, they are going to be 90 degrees out of phase. I shall do the sketch plot for you after this explanation. Okay, so something like this, sine 30 will give me the same answer as what? Cos 60. So if you should sum the two angles, you should see that it's what? 90 degrees. So the phase displacement between a sine, okay, and then what? A cosine is 90 degrees. Very well. So that is the relationship between these two. Okay. What are the tangents? Tangent is simply the ratio of the two. Okay? The ratio of sine and then what? Cosine. So tangent itself is the ratio of what? Sine of the angle over the cos of what? Whatever angle. So that is the relationship between the two. So this one and this are 90 degrees out of phase, and for tangent is the ratio of what? The sine and then the cos. So if I give you sine and its value, and I give you cos and its value, and I ask you to find the tangent or the tan. So let's say, since I'm using theta, I can say tan theta. Okay. So if I say you find tan theta, then it's simply the ratio of what? Sin theta and then what? The cos theta value you have there. And that's going to be your tan theta. Very well. So basically, when you want to graphically represent what we have here, then it's going to more or less be like this. The sine, okay, the sine is what we call the sine wave, right? The sine wave. And sine wave is like our normal AC currents we have. They are a sine wave, okay? It goes like this. It starts from, let's say, this is the axis in terms of what? The theta, the angle, and then this could be the amplitude. The amplitude could be anything, okay? The amplitude. So now, when it starts from here, then my sine over here is going to start from 0 and then drop back to 0 after 1 full 80. So at the peak here is what? 90 degrees. And at the place it drops back to what? 0 is 180 degrees. Okay? So that's how it looks. That's the first half of a sine plot. So let me write 180 here. But sine doesn't end. It goes again until it drops back to 0. So this is a periodic signal, so it will go down and then come back again to this place. So at this point, we still want to start a new one. So then we say, okay, then this is the nature of a perfect sinusoidal plot. Okay? Sinusoidal, which is coming from the word sine, right? Sinusoidal plot. So here is going to be what? 270, and here is going to be 360. So for a complete cycle which gives an angle of what? 360, a sine plot always goes what? This way. Okay. Now, if you should plot a cosine, then we say that the sine and the cosine, they are just 90 degrees out of phase. So because the sine is starting from 0, and then at the peak here, it gets to what? 90. Okay? At the peak over there, that is where the cosine plot will start from. So if you want to plot, you are giving values. Say your function, this one, your function is what? Y is equal to sine theta. So then you have this plot. Now if you are giving a new function, say y is equal to cos theta. Okay, y is equal to cos theta, then the plot of that is just going to look like this, just that it will be 90 degrees what? Shift, phase shift. So it's going to go this way. So for a cos plot, which the same thing, the amplitude, right, against what the angle. Then for this same thing, or you can say the period. Then for this, the cos is going to go like that. Start this way and then drop, and then go up, and then like this. So that's how the sine cos is going to go. So it is going to start from 0 here, and that's 90 degrees. And here will be 180 degrees. And then here is going to be 270 degrees. And then at this place here is going to be 360 degrees. So that's how a cosine works. A cosine works. So you can see that it's trying to imitate the sine, just that we shifted it. If you continue the sine, it will also go like this. So you can just shift it, and now you have a perfect cosine plot. Okay, a perfect cosine plot. Now for tangent, if you have a tangent plot, then with that you are going to have a plot like this. It's going to be two steps. So now let's look at this video. Okay. Now if I give you a situation like this, let's say this particular guy or this plot here is a wall, for instance, and then a ladder is leaning against this wall, and then that's the foot of the ladder, and then we tell you that okay, this thing is making an angle to the floor, let's say 30 degrees. Okay, 30 degrees. And then we identify this side. So let's name this triangle A, B, C. And mind you, for this specific ones I'm going to do, we'll work for right angle triangle. For other type of triangles, there are other rules we can use, the cosine rule and then the sine rule. But it's beyond the scope of this work. But then it's also possible to use the same trigonometry identities also to solve other questions involving different triangles, not specifically right angle triangles alone. Okay. So now with this here, let's say I've given you the length of line AB as say 22. Okay, let's say 2 meters. So I've given you the length of line AB as 2 meters. Let me write it bigger, as 2 meters. Okay. And then the question is asking you to find what? Line say BC, for instance. Okay, line BC. Or find line AC. Any part of what? This triangle that is there. Okay. Now when this happens, the question is, what are we going to do? Okay, what are we going to do? Now this is what we can do. Let's go straight to see what we can do. Now every angle that is here, we said that we can either use the cosine, the sine, or the tangent, depending on what you want to use. Okay, so if somebody decides to use cosine, there is a laid down formula for you. If you decide to use sine, there is a laid down formula, and then if you decide to use tangent too, there is a laid down formula for you. Okay. So if you have a situation like this, where you know the angle of one of the corners of this right angle triangle, say I know this place or I know this place. If you know one of the angles and one of the sides, it could be here, here, or here. If you know one of the angles and then one of the sides, then it becomes very easy to establish the rest or any part of what this triangle you are given. Okay, how then do we go by that? We go by that by employing some, should I say, acronym that is most commonly known as ka, and then tua. A lot of people know about that. So, right? And then we have ka, and then tua. These three. So, ka, and then what? Tua. What does this mean? What does this so ka tua mean? There's the very first letters are standing for the three trigonometry identities. The sine, cos, and then the tangents. Okay, they are standing for them. Then the middle ones and then the last ones, what then do they represent? What the so is saying is this: if you want to use the sine, then sine of whatever angle is given to you. So let's say that angle we don't know. So let's say angle theta. Sine of whatever angle is given to you is always going to be what? The O there means what? Opposite. So for instance, this angle that we are having here, the opposite of this, it means that what part of the triangle is this particular angle facing. So you can see that this angle, when you draw the direct opposite, it's going to what? Lie on this AB. So this line AB is going to become what? The opposite of this particular angle that you are doing. Okay, it's going to be the opposite of the angle. It's facing it directly. So that's why the opposite comes in. Okay. Now, if, for instance, the angle is not here, but it's rather here, then the opposite is now going to be this place. Okay, it's now going to be BC because the opposite is the line the angle is facing what? Exactly. That is what we call the opposite. So if we do this, so let's concentrate on the question we have. So this one is saying what? This is now the opposite. Right? Then if I establish the opposite, then it means that as for the long side, the longer side of a right angle triangle is always called the hypotenuse. The hypotenuse. Okay? The longer side is always called the hypotenuse. And where the angle is facing is called the opposite. So if you know the opposite and then you know the hypotenuse, then the angle, the other side where the angle is lying is making, or the other side, the BC, which is adjacent. You want to say adjacent is like it's beside you. Okay, the line that is just beside the angle there becomes what we call your adjacent. So then this one becomes adjacent. Right? So don't always keep it in mind that okay, for right angles, triangles, always the opposite is here and then the adjacent is here. It's not true. The opposite is at the place where it depends on where the angle is placed. So the opposite is where the angle is facing. So this time around, the angle is here. So it is facing this place. That's how come AB became our opposite. And then BC becomes your adjacent. But in the case where this angle migrates from this place to this side, then this place becomes your opposite, and then this place becomes what? Your adjacent. Okay? Becomes your adjacent. So I hope that is established. So then, if we identify these three parts, opposite, adjacent, and then the hypotenuse, then we can now relate to what this particular three, should I say, ratios are telling us. Okay? So the so now here, I'm sure is ringing the bell. Now you're saying that when you want to use sine theta, sine of that particular angle, then the O should be the opposite. Opposite divided by what? The hypotenuse. The hypotenuse. So that is how come the so came to play. So SOH. So sine is what? Opposite over hypotenuse. Fine. Now that is someone's choice. When you do this, and you punch your calculator, put everything right, do the proper change of subjects, your answer is going to show. But somebody says, oh, me, I can't, I don't want to use sine, I want to use cosine. Fine, you are also allowed to. But if you want to use cosine, then you must know that cosine goes with car. Okay? Where the car now means that cos of the angle is equal to the adjacent over the hypotenuse. So over the hypotenuse. Good. So then, if you want to use cos, then you should rather be the adjacent over the hypotenuse. And if you want to use sine, you should be the opposite over the hypotenuse. Okay? Then somebody will also say, oh, me, I don't want to use cos, I want to use tan. Fine. Tan is also accepted. Those are the three I introduced you to earlier. So tan is also somewhat accepted. So the tan is going to go like this. So tan of the angle should be toa, so O over A. So opposite over adjacent. So the opposite over adjacent. Opposite over adjacent. So anytime you are given an angle with with one of the sides known, okay, then you are at liberty to choose any of these three to work, okay. But then, depending on the question, you can be limited to the choices you make, okay. Depending on the question, you can be limited. For instance, let's look at this question we have now and see which of the three ratios are going to be easy. Okay, which of them is going to be easy? Okay, which of them? So now let's look at this. When I pick this question we established that per the position of the angle, we are going to have the opposite being at what? AB. Right? So the opposite is at what? AB. Very good. So AB is known. So our AB now is our opposite. Our AB is our opposite. So it's known. And then our adjacent is BC. Our adjacent is BC. So BC is our adjacent. That's fine. And then we know our AC to be the hypotenuse. Okay. Now, all these things, which of the sides is known per the question? Here, the opposite is known. So, we know the opposite to be 2 meters. Very well. What of the adjacent? It's not given to us. And the hypotenuse, that is also not given to us. Okay? That is also not given to us. So the question becomes, alright, then if I know only opposite, can I use cos? Because cos is not even making use of opposite. Right? So it means that in this case, cos is not going to be appropriate. Because adjacent is unknown, hypotenuse is unknown. So you have two unknowns in a given single equation. So the positions and the arrangement of these, we cannot use what? Cos. Per this specific question. Now if we want to use sine. Okay, sine, opposite is known. I can find sine theta because I'm given the angle. So it becomes only what? The only person that is not known for now is the hypotenuse. Okay, and that is just one equation. Just change of subject, you can have your hypotenuse. Very well. So it means that anybody who chooses to use sine for this question can actually get away with it or get along with it. Now let's look at tan. With tan, the opposite is known. Adjacent is not known, but we can find tan theta and then we can know the opposite. So it means that tan will also work. So like I was saying, always you can make a choice as to which of these three to choose from, okay? But the choice depends. The choice depends on the available parameters you have, okay? So let's now, with the knowledge we got now, let's now solve our question, okay? So let's start everything afresh, choosing one of the trigonometric ratios, and then we will look at it. So the question is asking us to find what BC is. So BC and then AC. That's what the question is asking from us. So we know our opposite here to be 2 meters. The position of the angle. Our opposite is now what? 2 meters. Okay. So let's use sine. So then sine theta, we know it to be what? Opposite over hypotenuse. Okay, we know our sine theta to be opposite over hypotenuse. So our theta is 30 degrees, so sine 30 degrees is equal to the opposite, which is 2. So 2 meters divided by the hypotenuse. What's the hypotenuse? That's AC. So line AC. Okay? So that's going to be AC. So we are looking for AC as per the question. It's asking for AC as well. So now let's look for AC. So with this, it's just change of subject. It's just a matter of change of subject. There is nothing so special about this. So sine 30 is probably going to be half. Okay? Sine 30 is going to be half. So this is going to be half is equal to 2 over AC. So that AC times 1 will be AC. And then 2 times 2 is going to be 4 meters. So our line AC is just going to be 4 meters. So basically we've been able to find the hypotenuse of this particular question using the sine. Okay. So that's how simple it is if you want to use the trig identities to do the solution. Okay. Now let's proceed to also use the same trig identity or trig ratios. Let me say ratio to solve for BC, line BC. So line BC is now the adjacent. So with now the hypotenuse known, you can choose to even use cos because you know the hypotenuse now. And you can even choose to use tan. Either ways, you are going to get what? The answer. That is if your hypotenuse is right. If you do it and it's right. Okay? So now let's use tan. So tan theta. So to find BC, here we are finding BC. Okay? So to find BC then, tan theta, which we know is 2r, is going to be what? The opposite over the adjacent. The opposite over the adjacent. So with these two known, it becomes very easy for us. So now the angle is 30, so tan 30 degrees is equal to the opposite, which is 2 meters over the adjacent, right? Over the adjacent, which is unknown. So that's going to be the line BC. Okay? Over the adjacent, which is line BC. So tan 30, right? So if you divide this over 1, you can just cross multiply this. Then this becomes BC times what? Tan 30. All this is equal to what? 2. And then we are after BC. We are after line BC. So BC then is equal to 2 over tan what? 30 Right, so I can just continue from this place. Alright, but we know tan 30 to be 0.58. Tan 30 is 0.58. When you divide sin 30 by cos 30, you get that 0.58. Or simply punch that on your calculator, you can get that. So tan 30 is 0.58, and so BC is going to be 2 divided by what? 0.58. And so if you do this, then your line BC is going to be 3.45 meters, right? So 3.45 meters. So that is just basically going to be this. So the idea is this. If you are given any of the sides, okay? If you are given any of the sides and an angle in one of the corners for a right angle triangle, then it becomes very easy for us to find any of the rest of the sides of this particular right angle triangle. And like I said, these three trig ratios I introduced you to works for only right angle triangle. For other triangles, then you can employ the cosine rule or the sine rule, which is normally in further mathematics, okay? So this is a basic math and common, so it's beyond our scope. But for any reason where you need to find any part of this, then you can employ these trig ratios to help you, okay? So we shall, in our next video, look at how to actually practicalize this, okay? And now look at how we are going to draw a particular structure of this nature if we are given, for instance, if we are given, let's say, a word problem, right? And then we want to deduce the right angle triangle from the word problem. How do we get it? For us to reach this page and then use the same idea, analogy we just learned in solving this, it becomes easy for us to do, okay? But then before I go, let's also try another example. Let's also try another example with regards to this particular question. So now let me put the angle in a new position. So we have the angle here now, being 60 degrees. Okay. So we have the angle now being 60 degrees. And then we know here, let's say we want to use 2 meters. And then for AB, let's say we are not giving any value for both sides, okay? So let's just follow what we did initially. So with this particular one, we are given another one which now has a new position for the angle, and then the other sides are not given to us, right? So we are asked to then find this side, say AC, and then side what? AB. So side AC and side AB. So employing the knowledge we just learned from our previous video, then it's going to be simple for us to solve this, right? Now, first and foremost, this is a right angle triangle because of the 90 degrees at the corner. And if we have 90 degrees at the corner, then we can identify the part of this triangle with respect to which side is the opposite, which side is the adjacent, and then which side is the hypotenuse. But we learned from our earlier example that the hypotenuse is always constant. That's the longest side, right? So our AC is always the hypotenuse. Fine. So now this time around, which one becomes my opposite? We said the opposite is the one that the angle is facing. So when you draw a line from where this angle is to any of this part, you could realize that this line BC is now facing the angle directly. Okay, so then line BC now becomes the opposite. And if this is now opposite, this is hypotenuse, then obviously the other side becomes your adjacent. Okay, so for this one to face here, if the angle was supposed to be here, it would have faced this place, right? So now let's just screen this place. Fine. So then, if we identify here to be your adjacent and then here to be your opposite, then we can choose any of the three trig identities, trig ratios we wrote: the so, the car, and then the toi that we wrote earlier. So what that is going to do is this. Let's say we want to choose what? Sine. Right? We want to choose sine. You can use cos, you can use tan, any of them, right? But depending on the information, you need to choose wisely, right? So now let's choose sine. Normally when you are giving opposites, you can choose only sine and then tan. When you are giving adjacent as a known value, then you can choose cos and tan, right? So if any other thing, then you should know how to do. If I'm giving the two sides, I can choose either sine or cos, or even tan to find the other side. That one is okay. Alright, so now with this known, then sine of the angle, so sine theta, we always know it to be opposite over the hypotenuse, according to the so I wrote for you. So sine theta is opposite over hypotenuse. So when you do this, then it's just going to be sine 60 is equal to the opposite, which is 2 divided by the hypotenuse, which is unknown. So our hypotenuse then is what? Line AC, right? Line AC. So when you actually cross multiply, okay, you cross multiply this to find AC. Then you have your AC being sine what? 60 is equal to 2. So your AC sine 60 is equal to 2. So if you divide through by sine 60, so if my line AC is 2 over sine 60, then you just have to punch this down, or know that sine 60 is root 3 over 2. So if sine 60 is root 3 over 2, then AC is going to be 2 over root 3 on 2. Okay? 2 over root 3 on 2. Then this is going to go up. So AC will actually become what? 4 over root 3. 4 over root 3 in meters. So you can convert this to decimals. If the question asks you to 2 decimal places, 3 decimal places, you can just quickly do that. Right? So then we know that the hypotenuse now is what? 4 over root of what? 3. So 4 over root of 3. Now if we know hypotenuse, we can just use what? Any of the rest to find this AD. We can use either sine, or we can use cosine. Sine has been used, so you can use cosine, or you can use what? Tan, okay? So if you do that, you can actually find one of the sides as expected. So let's find this side, what? AB, in this particular regard. So then we do this. By finding AB, side AB. So then this side AB here, let's use cos, okay? So cos of what? Theta. Cos of theta, we always know it as R. So R is adjacent over hypotenuse. So the adjacent, which is our side AB, over the hypotenuse, which we just found it to be 4 over root 3. So 4 over root 3. Okay. So let me just simply put it. It's a formula, so simply put AC. Okay. So this down becomes the general formula. Now my adjacent over the hypotenuse. So then if I put in the values now, then this will be cos 60 is equal to AB, which we don't know, so it's still like AB, over my AC here, which becomes my hypotenuse, 4 over root of 3. So this now becomes 4 over root of 3. This particular example. So if I want to know AB, I can just cross multiply this. Cross multiplication. Then my AB is going to just be cos 60, which is half. So half times what? 4 over root 3. So half times 4 over root 3, and this is going to cancel this to be 2. Then my line AB here is going to be 2 over root of 3. As simple as it's simple. So AB then becomes 2 over root of 3. And then whatever I sign it. So if it's in meters, you make it what? Meters. Right? So basically, that is what is required of you if you want to actually get to know this, right? If you want to get to know the sides of a particular right angle triangle using the trig ratios we have identified, then it's possible you can actually get it. Okay. Before we move to the practicalization of this whole application, let's say we can be given certain ratios and asked to find the other ones, right? So we look at that example before we go there, right? We'll see you there.
And he gave us a victory. Well, I'm talking about peace, 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 peace. He gave us peace and love. Well, I'm talking about joy, joy. The joy of the Lord is my strength, because it made me so happy, happy in the Lord. Listen, because it's just not the walls of the vision, and it brought me closer to my God. Yes, it makes me go wow, H-A-P-P-Y, H-A-P-P-Y. Yes, my Lord is so kind, kind, so kind to me, because my Lord